So I just wanted to talk a little bit about function notation and what it means, or perhaps more importantly, what it doesn't mean. So when we write something like f of x equals x squared plus 3, we're defining a rule, one that tells us what to do with an input with an x. So the notation f of x, what we're seeing here, again, it's really f of x. It means f evaluated at x, not anything like f times x. So when we see something like f of 4, again, this is f of 4 or f evaluated at 4. The idea of f times 4 doesn't really make any sense here. So when we see f of 4, that's telling us x is 4. It's telling us that our input value, our x, is taking on the value of 4. And so that would be, instead of x squared plus 3, x is now 4. That would be 4 squared plus 3. And in fact, anywhere we see an x in our equation, we're going to replace it with whatever's inside the parenthesis. So if we see f of a, then we'd have a squared plus 3. If we saw f of a smiley face, then we'd have smiley face squared plus 3, which of course doesn't really make any mathematical sense, but it's kind of cute. So now, it's worth mentioning that the choice of using a single letter f here for our function is totally arbitrary. To be honest, it's because mathematicians are lazy. So we were looking at, hey, we've got function of x. Function starts with f, so let's call it f of x. But we very well could have called it Fred of x, or Kermit of x, or something like that. In fact, if you're ever working in something like Excel or other computer programs, you'll notice that they tend to use longer function names. So for example, it's very common in Excel to use sqrt of x as a way of representing the square root of x, because typing a square root symbol on a keyboard is kind of difficult. And so this might help you sort of think about what's okay to do with functions. I mention this because I see a lot of students who will see something like f of 4, and they'll be thinking of f like a variable. So they'll think, hey, they'll think f times 4, and they'll write something like, they'll write it instead as 4f. So this is not the same thing, okay? This is not equivalent. Just like if you were to say square root of 4, you wouldn't write that as 4 square root, right? Square root by itself doesn't mean anything. Likewise, f by itself doesn't mean anything. So this is absolutely not okay. We can't do this. This is not equivalent, right? So in the same vein, we can't distribute a function. Okay, so it's, if we have something like f of 9 plus 16, we cannot write that as f of 9 plus f of 16. Again, this is not a variable that's multiplying, so we cannot distribute it. To see why that's true, it might be helpful again to think about our square root here. So let's imagine that our f function was the square root. So think about square root of 9 plus 16 versus square root of 9 plus square root of 16. Again, if f was the square root function. Here, 9 plus 16 is 25. Square root of 25 is 5. Here, square root of 9 is 3. Square root of 16 is 4. Those add up to 7. And you can see that those are not equal. The function of the sum is not equal to the sum of the function. So just a couple things to be careful of here, right? So function evaluation is not the same as multiplication. Function evaluation does not distribute. You really want to think, when you see this, you really want to think this is f evaluated at x, not f times x.